Welcome. Today session on decision science is on linear programming methods, and we are going to do a graphical. Hello, welcome to my next session on decision science. Today we are going to use the graphical method to solve the minimization problem. The example which we have taken today is a minimization problem. The objective function is 80x1 plus 120x2 and the constraints x1 plus x2 less than equal to 9, x1 is greater than equal to 2, x2 is greater than equal to 3, 20x1 plus 50x2 is less than equal to 300, and we also have the non-negativity constraint x1 and x2 both are greater than equal to 0. To begin with the solution, let us find out the coordinates for the first constraint line. So let us write the first equation. The first equation is x1 plus x2. Now instead of less than equal to sign, I'll make use of the equal to sign here. So I am going to remove this less than sign so that my constraint equation is now x1 plus x2 equal to 9. We put x1 equal to 0, therefore we get x2 equal to 9. You can see this is my point A with the coordinates 0, 9. Similarly, I'll put x2 equal to 0, okay. Therefore, x1 will be 9 now, and we can take this as point B. We get the coordinates 9, 0. Okay. Let us take the second equation. Now, second equation has only one variable x1, which is given as greater than equal to 2. Okay. So therefore, we have a constraint equation x1 equal to 2. That is, we have a parallel line. A parallel line which is to the x-axis. So the point a parallel line at, you can say, let me change this, a parallel line at say 2, 0. Okay. So this line will be parallel to your y-axis. The third one, where we have x2 is greater than equal to 3, I can equate this, therefore x2 is equal to 3. That is, again we have parallel to a parallel line at 0, 3, okay, to the this will be x-axis and to y-axis. So for a better understanding, we will put the axes. The fourth equation, we have 20x1 plus 50x2 greater than equal to 300. We will equate this so that my constraint equation becomes now 20x1 plus 50x2 equal to 300. Okay. We can reduce this further, divide throughout by say 10. I get 2x1 plus 5x2 equal to 30. Okay. Okay. Now I will assign x1 as 0. So put x1 equal to 0. Once we do this, I get therefore x2 equal to 6. So let us give some points here. I'll name this as C. So this is my point C with 0 comma 6 as the coordinates, and when we put x2 equal to 0, we get x1 equal to 15. So this will be D 15 comma 0. Clear? So let us come to the graph now. I will be plotting all this points and draw the lines on the graph. So here I have got the graph here. I have the x coordinate where I have taken 1 centimeter equals to 2 units. Okay, and on the y axis I have taken 1 centimeter equal to 1 unit. We have the origin O 0 comma 0. Let us plot the first line. Okay, to plot the first point on the graph, we have a 0 comma 9. So on the x axis we have 0 and on the y axis 9. So my first point will come at this point here. So this is my point A, and similarly we'll put the point B, which is 9 comma 0. So 9 is between 8 and I'll just pick up this center point and make this as point B. Okay, we will join these 2 points. So here we go, we have this line drawn. Okay, one more thing we have to notice is in the actual equation, what is my operator? The less than operator is used here. That means if I draw this line, my feasible region will be towards the origin, that is 0 comma 0. So I need to draw a arrow. So we are going to draw 2 arrows here and here, which is indicating the direction of my feasible region. Let us see the next one. We have here, we have a parallel line to your y axis. So the point is 2 comma 0. So this is my point 2 comma 0, and I'll be drawing a parallel line. So to do that, because this 1 centimeter, I'll just take 1 centimeter here, so that my point is, I can draw a parallel line. So draw. Okay, so this is my parallel line. This is 2 comma 0. We'll leave this as it is. The next one is again a parallel line to your x axis at 0 comma 3. So this is my 3 here. So from this point I will draw a parallel line. Let me now again, what about the arrows? X1 was greater than equal to 2. Greater than means my feasible region will lie away from the origin. So the direction is this one. Even in this case, it is this side. For the next parallel line, x2 was greater than equal to 3. Again, it will be away from the origin. So like this above. Okay, I can put this sign here as well. My third or the fourth line has 2 points, 0 comma 6. So 0, y is 6. So here it is. let us call this point C, and your D is 15 comma 0. So here we have between 14 and 15, yeah, 16 we have, I'll take this center point, okay, call this as D, join these 2 points, okay, and if you look at the sign, we have less than equal to 300 in the actual constraint. So less than means it is going to lie towards the origin. So my feasible area direction will be towards the origin. Okay. Now let us give some point names to the intersection of the lines. So I'll randomly give it. Let us start. We have B, C, we have D. Let us give you E. This is my E. I'll give this as F, G here, and I'll give this as H. Okay. So I have given the intersection some points here, and why I am giving it here is because if you carefully look at the arrows which we have drawn, we'll come to the conclusion that this area in between is my feasible area. Okay. So this becomes my feasible area. You can see this, whether it's checking all the constraints, you can see this direction, then this one, then this side, okay, down direction. Fine. This will give me this area as my feasible area. So you can see, I'll just write down feasible region is, okay, I'll write E, F, G, H, E. Okay, this is my feasible region. Now once we get this feasible region, I need to use the points, the values of these points, okay, and find the value of Z, and the one which is minimum will give me the optimum solution. Now to find the coordinates of each point E, F, G and H, we need to check which two lines are crossing and forming this point. Using this two lines equation, I can easily find out the value of E. Okay, so E, let us find out the value for E. What is E here? E lies on two equations. So if I want to number this lines also, I can number it and then use it. So on the first equation is x 1 greater than equal to 2. This is my equation. And what is the other equation? This is my other equation, which says x2 is greater than equal to 3. Now using these two equations, we can easily find out E coordinate will be 2, 3. Okay, easy. Now let us check whether we can find out the coordinates for F here. So F lies on similar x2 greater than equal to 3, and which is the other equation, this one for AB. AB is x1 plus x2 less than equal to 9. This was the two equations. Okay, so using this I can directly substitute 3 in as x2 and find out the value of x1. Okay, so x2 is 3. So if x2 is 3 and we substitute 3 here, x1 will be how much? 6. Okay, and please remember we have to use the equal to sign. while solving the problem. Therefore, we have f as 6, 3. Fine. So, f is 6, 3. Let us find the value for g now. For g, we have two different equations. The equation number 1, x plus, so we will write here point g lies on, we have x1 plus x2, we had greater than or less than sign, less than, equal to, I will just put equal to 9, and the last one was 2x1 plus 5x2 equal to 30. Okay, these were the two equations which we had used. Okay, let us solve this now. Multiply by the first equation with 2. Okay, so let us say 2x1 plus 2x2 is now equal to 18. 2x1 plus 5x2 is equal to 30. Now, solve this problem, equate it. We can do the subtraction, minus, and this also, because minus, this goes off. So, minus 3x2 is equal to minus 12. Therefore, x2 is equal to 4. Okay. Use any one of the equations from above and substitute x2 as 4. I get x1 plus 4 equal to 9. Therefore, x1 is equal to 5. So, what is point G here? Point G will be 5, 4. So, G is 5, 4. What is remaining? H is remaining. So, point H lies on, we had the last equation, that is 2x1 plus 5x2 equal to 30, and we had the parallel line x1, let us say, equal to 2. So, directly we know x1 is 2. So, substitute x1 as 2 here. So, this will be 4 plus 5x2 equal to 30. 5x2 is equal to 26. Therefore, x2 is equal to 26 upon 5. Clear? So, what is h coordinates? H coordinates are 2, 26 upon 5. If you want, you can write this in decimals as well. Okay, I am keeping it as it is, so it becomes easy for me to do the calculations while finding the value of z. Okay, now let us calculate the values of z at corner points of the feasible region. Okay, at E. So, first one at E. What was E coordinate? 2, 3 was the coordinate. So, Z is equal to ZE, I will put here, is equal to 80 into 2 plus 120 into 3. Now, what is the objective function? You can go through the objective function once again. It is 80x1 plus 120x2. So, we are going to use this objective function here and find out the values. Okay, this gives you 160 plus 360, that gives you 520. At the next region, we have F. Okay, the coordinates for F were 6 and 3. F was 6 and 3. So, this is 6, 3, ZF equal to 80 into 6 plus 120 into 3. Okay, that gives you 480 plus 360, 840. The third point at, let us use G. What is the coordinate for G? 5, 4. 5, 4. Z. G is 80 into 5 plus 120 into 4. 80 into 5 will give me 400. 400 plus 480. That gives you 880. Okay. Finally, the last point at H, which is 2, 26 upon 5. 80 into 2 plus 120 into 26 upon 5. Now, please do the calculation. So, this is 160 plus 5 ones are 5. Let us do the calculation. 5 ones are here, 2s are 10, 4s are. Okay. So, 24 into 26, that gives me, let me use the calc here. Okay, it gives you 624. So, 160 plus 624, which gives you the final answer 784. Okay. Since 520 is your minimum value, so we will write here the solution. Since it is a minimization problem, since ZE is equal to 520, which is minimum. Okay. The optimum solution will be Z min equal to 520 at which point? 2, 3. At E 2, 3. Got it? So, this is how we write the final solution. I hope you have understood this. Go through each step, especially how to draw the lines and get the feasible region, and then using this lines of intersection, find the coordinates of each point. Use this corner points in the objective function to find the final solution. Okay. I hope we have understood this. Please go through the video once again and try to solve this problem. Thank you.